Our world holds a realm more alien than any distant planet we've yet explored. It is a place of perpetual night, crushing pressures, and unimaginable cold, hidden beneath miles of seemingly placid water. These are the ocean's deep-sea trenches, scars on our planet's surface, holding secrets that defy our understanding of life itself. For centuries, the deep ocean remained an impenetrable mystery, its depths believed to be barren and lifeless. Early expeditions ventured only so far, their primitive technologies unable to withstand the immense forces lurking below. The ocean floor was an unknown, a silent, dark void. The true revelation began in the late 19th century with the Challenger expedition, 1872 to 1876. This pioneering British scientific voyage circumnavigated the globe, taking soundings and dredging the seafloor. They found life at depths previously thought impossible, shattering long-held scientific assumptions. It was during this monumental journey that the first deep-sea trench was definitively identified, the Mariana Trench in the western Pacific Ocean. Its sheer scale was astonishing, hinting at a world far more complex and extreme than anyone had ever imagined. This colossal chasm plunges nearly 11,000 meters, or almost 7 miles, into the Earth's crust. If Mount Everest were placed within it, its peak would still be more than a mile below the surface. It represents the deepest point known on our planet. The formation of these trenches is a violent dance of geology. They occur at subduction zones, where one tectonic plate is forced beneath another, scraping against each other and dragging sections of the ocean floor downwards into the Earth's mantle. Beyond the Mariana, there are dozens of other deep trenches around the world, primarily concentrated in the Pacific Ring of Fire. The Tonga Trench, the Philippine Trench, the Kuril-Kamchatka Trench, each a unique geological wonder, a vast canyon of the deep. Early attempts to explore these depths were fraught with peril. Submersibles had to be engineered to withstand pressures hundreds of times greater than at the surface, where a typical human diver would be instantly crushed. It was an engineering nightmare. In 1960, the Bathyscaphe Trieste, piloted by Jacques Picard and Don Walsh, made history. They successfully descended to the Challenger Deep, the deepest known point of the Mariana Trench. This pioneering feat proved that humans could reach these extreme depths. Their journey was slow and agonizing, taking nearly 5 hours to reach the bottom. They spent only 20 minutes there before ascending, a brief glimpse into an unknown world. The pressure on the hull was immense, estimated at 1,100 standard atmospheres. What they saw was sparse, a single flatfish and a shrimp, proving life could exist even under such hostile conditions. It was a monumental step, but only hinted at the biological diversity that truly thrived within these abyssal realms. This early exploration shattered the myth of the lifeless abyss, opening a new frontier for science. Yet, the extreme conditions, particularly the crushing pressure, presented a profound challenge. How could any organism survive, let alone flourish, in a world where steel bends like clay? The deep ocean trenches are laboratories of extreme survival. Here, sunlight never penetrates, meaning photosynthesis, the foundation of most life on Earth, is impossible. The water temperature hovers just above freezing, and the weight of the water above is crushing. The pressure at the bottom of the Mariana Trench is over 1,000 times that at sea level, roughly equivalent to carrying 50 jumbo jets. Imagine that force exerted on every square inch of an organism. It's a challenge that demands extraordinary biological adaptations. Deep-sea creatures have evolved unique molecular structures to prevent their proteins from denaturing under such immense pressure. They possess specialized enzymes and often lack gas-filled organs that would simply collapse, like swim bladders. Instead of photosynthesis, trench ecosystems rely on chemosynthesis. This process uses chemical energy from hydrothermal vents and cold seeps, where bacteria convert hydrogen sulfide and methane into organic compounds, forming the base of the food web. One of the most iconic trench inhabitants is the Mariana snailfish, or Pseudoliparus swirii, discovered in 2014. These translucent, tadpole-like fish hold the record for the deepest living fish, thriving at depths of up to 8,178 meters. Their gelatinous bodies and lack of rigid bones are key adaptations. Their soft, almost liquid-like bodies allow them to withstand pressure that would shatter other vertebrates. They move slowly, conserving energy in an environment of scarce resources. Another common sight are the amphipods, tiny, shrimp-like crustaceans that scavenge the trench floor. These detritivores are crucial to nutrient cycling, consuming falling organic matter from the surface and preventing its accumulation. In 2012, filmmaker James Cameron descended solo into the Challenger Deep in the Deep-Sea Challenger submersible. His expedition captured high-definition footage and collected samples, offering unprecedented views of this alien landscape. Cameron reported seeing vast expanses of desolate, muddy plains, but also surprising signs of life. His footage revealed unique jellyfish, sea cucumbers, and bizarre anemones, suggesting a biodiversity far richer than previously thought. The trench wasn't barren at all. These creatures often exhibit gigantism, a phenomenon where deep-sea organisms grow much larger than their shallow-water relatives. The Japan Trench, for instance, is home to the colossal amphipod Alicella gigantea, reaching up to 34 centimeters in length. The exact reasons for deep-sea gigantism are debated, but theories include cold temperatures slowing metabolism, abundant food supplies from surface fallout, and reduced predation pressure. These larger bodies might also be more efficient in nutrient absorption. From the ghostly snailfish to giant amphipods, the trench ecosystems showcase an astonishing array of adaptations. Yet, for every creature we identify, countless others remain undiscovered. What other unfathomable forms of life might be lurking in these unexplored abysses, challenging our very definition of what life can be? Despite significant advances, our understanding of deep ocean trenches remains in its infancy. Less than 5% of the global seafloor has been thoroughly mapped, and even less has been explored visually. These depths remain one of Earth's greatest unknowns. Modern autonomous underwater vehicles, or AUVs, are revolutionizing trench exploration. Robots like the Nereus, developed by Woods Hole Oceanographic Institution, can dive to full ocean depth, collecting data and samples without human risk. These sophisticated robots use advanced sonar, high-resolution cameras, and robotic arms to investigate the trench floor in detail. They send back unprecedented imagery, revealing geological features and organisms never before seen by human eyes. Recent expeditions have unveiled entirely new species with astounding regularity. In 2021, a new species of jellyfish, Bathycyro fosteri, was discovered in the Puerto Rico Trench, an iridescent marvel illuminating the dark waters. Beyond biology, trenches are critical for understanding Earth's geological processes. They represent crucial zones of carbon sequestration, where organic matter is drawn deep into the Earth's mantle, influencing our planet's climate over geological timescales. Sadly, even these remote, extreme environments are not immune to human impact. Microplastics have been found in the stomachs of amphipods collected from the deepest parts of the Mariana Trench, a stark reminder of our global footprint. Chemical pollutants and persistent organic contaminants have also been detected in trench fauna. These substances travel through the food chain, accumulating in the organisms at the bottom of the world, far from their point of origin. No corner of Earth is truly untouched. The trenches also hold potential for unique biotechnological discoveries. Enzymes from extremophiles living under immense pressure could have applications in medicine, industrial processes, and even bioremediation, offering solutions to human challenges. Protecting these fragile, unique ecosystems is paramount. International efforts are underway to designate marine protected areas in some trench regions, recognizing their invaluable scientific and ecological significance for the entire planet. Yet, the allure of the unknown persists. With every new dive, every new sensor deployment, we chip away at the mysteries. What larger, more complex ecosystems might exist, hidden in the vast expanses yet to be surveyed? Could there be undiscovered life forms with metabolisms entirely alien to what we understand, existing at pressures and temperatures once thought impossible? The possibility pushes the boundaries of biological theory and ignites our imagination. The deep ocean trenches are not just abyssal pits of crushing darkness, they are vibrant, extreme worlds teeming with life forged under unimaginable conditions. As humanity gazes outward at the cosmos, perhaps the greatest alien frontiers lie not in distant galaxies, but thousands of miles beneath our own feet, waiting to be truly known.